video of electromagnetic theory, and we are going to do the problems from the session Waveguides. So Waveguide numericals you cannot really find over the internet a lot. So that's why I'm including the numericals only. And I've done a separate video on the formula revision of rectangular waveguides. So if you are watching this video, I would recommend you to first watch that theory video, because then it is very useful for you to remember the formulas and apply in this numericals. Okay, so anyway, let's see what is the first question. A rectangular metal waveguide filled with a dielectric material. So the rectangular waveguides can be either filled with some dielectric or it can be filled with air. Okay, here it is filled with a dielectric material of relative permittivity epsilon r equal to 1. Has the inside dimensions 3.0 centimeters cross 1.2 centimeters. So this is nothing but A by B. So this is A by B, where A is a wider dimension, B is the narrow dimension. Okay, so these were all the basics of rectangular waveguide. So please do watch the video. Okay, the cutoff frequency for dominant mode is dash. So we have to find what is the cutoff frequency for the dominant mode. Now the dominant mode will be having the cutoff frequency which is a minimum frequency. So the minimum cutoff frequency is for the dominant mode. Okay, now since this rectangular waveguide is filled with a dielectric material, first we need to find what is the speed of the wave within that waveguide. So for that we will find the speed or velocity V is equal to C by square root of epsilon r. Now why this is being used? Because here it is filled with a dielectric material. So we have to take into consideration its relative permittivity to find the speed. So C is 3 into 10 raised to 8 meter per second by square root of 4. Okay, square root of 4 is nothing but it is 2. So you will get 3 into 10 raised to 8 meter per second by 2, or it will be equal to 1.5 into 10 raised to 8 meter per second. Okay, so this is the speed of the wave within the waveguide. Okay, now we need to find the dominant mode. Dominant mode's cutoff frequency. And for that, first we need to find what is the dominant mode. See, the question is regarding a rectangular waveguide. And we know that while discussing the theory also, I have mentioned that the rectangular waveguide has a dominant mode which is equal to TE10. Please note it somewhere because it can come as theory questions also. TE10 is the dominant mode for a rectangular waveguide. Now we need to find the cutoff frequency for this mode. Okay, I'm going to apply the equation for cutoff frequency. I hope you have noted the speed, because we need that for finding the frequency. Okay, so Fc is equal to the speed by 2. Generally you can see here C by 2, but this is a dielectric material type of rectangular waveguide. That is, it's filled with dielectric material, so you have to apply that speed. V by 2 square root of this is a very famous equation, and if you don't know, please note it down. M by A square plus N by B square, and we are finding for T10. Now the general way of notating a mode is Tmn. Okay, so M is here and N is here. Since this is Tmn is equal to T10, what is M? M is equal to 1. What is N? N is equal to 0. Now you can substitute the values of M and N here. Okay, so these are actually the general steps which you have to follow while attempting the rectangular waveguide questions. Okay, now I'm going to substitute the speed here. 1.5 into 10 raised to 8 by 2 into square root of M is 1. A is given here. See, it is A by B. A by B is 3 cross 1.2, and very important thing to note that this is in centimeters. Here this is in meter. So either you convert this to centimeter or this to meter. So I'm going to convert this centimeter values to meter values. So 3 centimeter is nothing but 0.03 meters. Okay, square plus n is 0. So that term will get cancelled out. Okay. So this is square of square root is nothing but the value itself. So you can cancel off this square root and you will get this. And 1.5 into 10 raised to 8. In the denominator, you will have 0.06 if you take the product of these two. Now, if you solve it, the answer getting is 2.5 gigahertz. Okay, so I'm going to give you another important thing to note that, see, while doing these type of either wavelength questions or frequency questions, when taking A and B, they will be given in centimeters 99% of the time. Because this is a rectangular waveguide, so you will be given only centimeter dimension. They are in centimeter dimensions. So you have to either convert this to meters or this speed meter per second to centimeters per second. Okay, so into 10 raised to 2. So you have to always do it. Otherwise, your calculation will go wrong. Okay, so the correct answer here is 2.5 gigahertz. This 2.5 gigahertz is the cutoff frequency for the dominant mode, and note that TE10 is the dominant mode. The next question that we are going to attempt today is this: a rectangular waveguide having TE10 mode as dominant mode. See here it is specifically given TE10 is a dominant mode. So this is the theory question. Okay, TE10 is the dominant mode for a rectangular waveguide. Okay, now is having a cutoff frequency of 18 gigahertz for TE30 modes. That is another mode. It is having a cutoff frequency 18 gigahertz. Okay. The inner broad wall dimension of rectangular waveguide is dash. So you need to find what is the inner broad wall dimension. Now, what is the letter denoting this broad wall dimension? I have mentioned that. See, this is the structure of a rectangular waveguide. It is having a broader dimension. A rectangle is generally having a broader dimension and a narrow dimension. The broader dimension is denoted by A and the narrow dimension is denoted by B in most of the time. Okay. So in all the textbooks, standard textbook, you can see like this, A and B. Now, here we need to find for this question, you need to find not B, only the broad dimension, which is A. Now, what all things have been given? The cutoff frequency is given, which is FC is equal to 18 gigahertz, or you can write it as 18 into 10 raised to 9 hertz. That is FC. Now we know that the cutoff wavelength lambda C is equal to C by FC, general relation of wavelength and frequency. Lambda is equal to C by F, right? So we can put it here. Lambda C is equal to C is 3 into 10 raised to 8 by FC is 18 into 10 raised to 9. You will get it as 1 by 60. So this is lambda C. Now you don't need lambda C, you need A. How can we connect lambda C with A? That is just by applying the equation for finding the cutoff wavelength in terms of A and B. And in that equation, you have to substitute the values of T30 mode, right? So you have to put M is equal to 3 and N is equal to 0 and reduce that equation. And you will get the cutoff wavelength equation lambda C for TE30 mode as 2A by M. Okay, please note this down, because if you reduce only, you will get that the cutoff wavelength for T30 mode as 2A by M. Now A is the, what is A? A is the value actually we need to find. It is the broad wall dimension. Now, and what is M? M is equal to 3. Okay. So this is the equation for the cutoff wavelength for a TE30 mode. And in that, substitute M equal to 3. I'm going to substitute that and then I'll be equating with this value. Now, then I'll be getting A. That is a simple logic. Okay. I'm going to equate 2A by M is equal to 1 by 60. 2A by 3 is equal to, since it is TE30, M is equal to 3, N is equal to 0. 2A by 3 is equal to 1 by 60. From that, you will get A is equal to 1 by 40. That is 5 by 2 centimeters. See, as I told, most commonly A will be seen in centimeters. You have to convert while doing numericals to meters or some standard unit. Okay, so A is obtained as 5 by 2 centimeters or 1 by 40 centimeters is the answer for the inner broad wall dimension. Question is a little bit lengthy question, but if you know the general equations, then it is very easy to solve. Okay, first the biggest task is to read and understand the question. Okay, anyway, we'll make it easy. The longitudinal component of the magnetic field inside an air-filled rectangular waveguide. So here the rectangular waveguide is filled with air. Okay, so the longitudinal component of magnetic field. Okay, the longitudinal component of magnetic field inside an air-filled rectangular waveguide made of a perfect electric conductor is given by the following expression. So what is given here? Here they have been given the longitudinal component of magnetic field. Hz of xyzt is equal to 0.1 cos 25 pi x cos 30.3 pi y cos 12 pi into 10 raised to 9 t minus beta sl. So if you have watched the revision of rectangular waveguides video, you could have related this equation with the general equation. Okay, anyway, if you know the general equation, then you know that this is how we represent various components of magnetic field. You have magnetic field in x, y, z directions, and its value will vary. Okay, for various values of x, y, z, it will vary. Now, the cross-sectional dimensions of the waveguides are given as A equal to 0.08 meter and B equal to 0.033 meter. So here if you see, both the dimensions are given in meters. Okay, sometimes you can also find like this. Then it is easy for you to solve. No need for converting the units. So A and B is given. So that's why I'm saying just have a idea about the variables. A is a wider dimension, B is a narrow dimension. Okay, so you should be familiar with the basics. The mode of propagation inside the waveguide is that. So they are asking simply the mode of propagation. What is the mode of propagation? Okay, how to find whether this mode is TE mode or TM mode? Okay, generally you can have two types of modes in a rectangular waveguide, that is transverse electric field modes and transverse magnetic field. It is represented as TM. Magnetic field modes, right? Now, when the mode is TE mode, then the electric field component Ez is equal to 0, where Z is the direction of propagation. Then when the mode is TM mode, that is if the mode within the waveguide is transverse magnetic field mode, then H of Z should be equal to 0. Okay, so this is the condition. Please note the condition. In order to find what is the mode of propagation and what is the values of M and N of the modes, first we have to start from thinking that whether it is a transverse electric mode or transverse magnetic mode. If the mode was transverse electric, then Ez has to be 0. Then if the mode is transverse magnetic, then H of Z has to be 0. But if you examine the question, H of Z is not 0. It is having a value. So it is very clear the mode is not TM. Okay, I hope the concept is clear. I hope what I am explaining is understandable for you. Okay, so we have to find what is the mode of propagation. And the various modes are, or the various types of modes are TEMN and TMMN. Transverse electric field mode with various values for M and N. Then transverse magnetic field modes with various values of M and N. M and N can have various values, 0, 1, likewise. Now, if the mode was TE, then E of Z has to be 0. If the mode was TM, H of Z has to be 0. These are the two conditions. If you don't know anything, please note this down because it is the starting point of doing this question. Now, if you see here, as I've told, H of Z is not 0, it is having a value. So, the mode is not TM and the mode is TE. Okay, I hope it is clear. So, we have to find the values for TE, M and N. So this is the mode, and now we need to find what is M, what is N. Then we'll get the mode of propagation. Okay. Now how to find M and N? That is only possible by equating this with the general equation of your magnetic field. And it will be known to you if you see the videos. Not only my video, you can find a lot of other videos on rectangular waveguides. There you can find the general equation for the magnetic field. Okay. Now I'm going to find the values of M and N. So for finding the value of M and N, you have to equate these terms. You can see here there is a 25 pi x, right? And in the general equation, this 25 pi x is equal to m pi by a into x. Okay, so m pi by a x is equal to 25x in this, for this particular wave. Okay, now from this, can't we find m? Yes, because a is given to you, see. And it is also in meters, so no need for converting the units. Now I'm going to cancel pi and x. You will be getting m is equal to 25 into a. What is a? 25 into 0.08, and that is 2. Right? You have obtained m is equal to 2. Next, I'm going to find what is n. Similarly, by equating this equation's terms with the general equation. Okay. So this term is m pi by ax, and this is n pi by by. Okay. So this general equation is h0 cos m pi by ax cos n pi by by, and this is a term cos 2 pi. Okay. So this is cos n pi by by. Now I'm going to equate that with 30.3 pi y. Okay. So we can equate 30.3 pi y is equal to n pi by by. So pi and y gets cancelled. N is equal to 30.3 into what is b? It is 0.033. And it is obtained as 1. Taking the product, you will get 1. Now, what is the value of 1 obtained? Sorry, n obtained, it is 1. So, you got m is equal to 2, n is equal to 1. So, it is TE21. The mode is TE21 is the mode. That is transverse electric field mode 21 is the mode of propagation of this wave. Okay, so if this is the longitudinal component of magnetic field, then the mode is TE21. Okay, I really hope that you understood this question, how to do this question. Okay, so first you have to actually find what is the type of mode, whether it is TE or TM. For that, apply the logic which we have applied in the beginning. Then find m and n by equating with the general equation. Then you will be finding the mode. Okay, the mode is TE21. I hope that you understood to do this question. Okay. The last question that we are going to see is this: a rectangular waveguide of internal dimension a equal to 4 cm, b equal to 3 cm is to be operated in TE11 mode. Okay. So when you are seeing TE11, when the moment you see TE11, you have to note m equal to 1, n equal to 1. Okay. The minimum operating frequency means cutoff frequency for that mode. Okay. Anyway, that is not the dominant mode. Just we are finding the minimum operating frequency. Now, the minimum operating frequency for this mode FC is equal to C by 2 square root of m by a square plus n by b square. Okay, this is a general equation. Earlier we have used V here. I really hope you have understood that because there was a dielectric. Now, C by 2, substitute it. Okay, another thing, note that A and B are in centimeter. So, either convert this to centimeter, there is C. C is in meter per second, right? So, either convert that to centimeters per second or convert these units to meters. You can have a choice, but in the end, you should equalize. Okay. So, 3 into 10 raised to 8 into 10 raised to 2. I am going to substitute like this. Then, by 2 square root of 1 by 4. M is 1 by A is 4. So 1 by 4 square plus 1 by, this is 1 by 3 square. Okay. Now, if you solve it, you will get the value as 6.25 gigahertz. I'm telling it once again, if you have not equalized the units, that is, if you have not converted either both to centimeters or either both to meters, you won't get it as gigahertz. You will get the 6.2, but you won't get it as gigahertz. Okay. So please convert both to same units, either centimeters or meters. Okay. Anyway, the cutoff frequency or the minimum operating frequency for this T11 mode is 6.25 gigahertz. Okay. So these are the questions which I have included in this video. I hope that you understood some concepts at least regarding rectangular waveguides. If you have no idea about rectangular waveguides, I hope that you understood at least some points. Okay, so these are some of the very important type of questions. I have not stuffed in lots of questions because I am giving enough explanation for each question, each equation and everything. So that is, I think that is useful, right? Rather than just reading the question and writing the answer. There's no point in doing a lot of questions. There is point in reading minimum questions with maximum explanation. That is the concept. Okay. So I really hope that you found this video useful. We'll be continuing these videos or these type of questions from Waveguides. If you request to, that is, if you want me to do more questions on this more question on this topic, we'll be doing it. And also, we have not done the theory video of circular waveguides, that is pending. We'll be doing that. After that, we'll be including the questions from circular waveguides also. Okay, so if you found it useful, please do like it. Please do share it. There is a lot of competitive examinations for electronics branch. Please do share it with all your friends. And if you want more videos, please do subscribe to the channel. Please do follow the Facebook page of EC Electronics. There you can find the videos of the notes of almost all videos I'm uploading there. You can download it from there. Okay, so that's it. Thanks for watching and keep on watching.